Hi everyone, this is Ashley Bedford, founder of the Runtime Diaries, and we are super excited for day 21 of our hashtag 30 Days of Code Challenge with Educative. So let's get into this interesting problem. Today, we're looking at a clean, lightweight problem that teaches an important lesson. Just because you can use a complex data structure doesn't mean you should. This is the check if a word occurs as a prefix problem from LeetCode 1455. It's straightforward on the surface, but it's also the perfect example of choosing the right amount of power for the job. Let's dive in. Here's the setup. You're given a sentence where every word is separated by a single space, and you're also given a search word. Your job is to return the one indexed position of the first word in the sentence that starts with that search word. If no word starts with the search word, you return -1. Here's an example. The sentence is, I love eating burgers. And the search word is burg, B-U-R-G. The answer is 4 because the fourth word in the sentence is burgers, and burgers starts with burg. That's the entire problem. Before we go further, let's make sure we're aligned on what a prefix actually is. A prefix is simply the beginning of a word. For example, pro is a prefix of program. Int is a prefix of integer. But cat is not a prefix of scatter because cat appears in the middle of the word, not at the beginning. We're not doing substring search here. We're only checking if the first characters of each word match the search word. That distinction is important. If we think through this problem naturally, the brute force solution is also the optimal solution. Here's the human thought process. First, split the sentence into individual words. Second, loop through those words from left to right. Third, for each word, check if it starts with the search word. Fourth, if it does, return the position of that word immediately. Fifth, if you finish the loop without finding any matches, return -1. There's no trick here. This is exactly what we're supposed to do, and it's the most efficient approach for this problem. This is one of those problems where the pseudocode is almost identical to the final code. You split the sentence into words. You loop through the words with their index positions. For each word, you check if it starts with the search word. If it does, you return the index +1, because the problem asks for 1 index positions, not 0 indexed. If you finish the loop without finding a match, you return -1. That's it. Nothing else is needed. In Python, this becomes extremely clean because strings come with a built-in method called startswith. You split the sentence into words. Then, you loop through the words using enumerate, which gives you both the index and the word itself. For each word, you check if it starts with the search word using the startswith method. If it does, you return the index +1. If the loop completes without returning, you return -1. This solution passes all test cases. It's intuitive, it's readable, and the runtime is excellent because sentence lengths are small. Now, we get to one of the most important lessons from this problem. You might look at this and think, well, this is a prefix problem, so should I use a trie? And the answer is no. Tries are fantastic data structures when you have a huge dictionary, when you need to store thousands of words, when you have many prefix queries, or when you're building autocomplete systems or search engines. But here, you have one sentence with maybe 5 to 20 words, and you have one search word. A trie would add overhead without making anything faster. In fact, it would make the solution slower because you'd spend time building the trie structure just to use it once. This is a case where the simplest approach is the optimal one. I still want to highlight when a try would be the correct solution because understanding when to use a data structure is just as important as understanding how to use it. Tries make sense when you need fast multi-query prefix lookups, when you have a large word dataset, when you're querying many potential prefixes, or when you're building keyword search engines or predictive text systems. This problem is not that. This is a single pass, single query, tiny input problem. The smallest approach is the most optimal one, and that's an important lesson to internalize. If you really want to reduce overhead, here's a slightly more micro-optimized approach. Rather than using the startswith method, which involves a small amount of Python internals and a function called overhead, you can manually check the prefix yourself. First, you get the length of the search word once, outside the loop. Then, for each word, you check if the word's length is at least as long as the search word. If it is, you compare the first few characters of the word directly to the search word using a slice. This avoids the overhead of the startswith method and avoids unnecessary slice allocations. This is a small optimization, but it's a good example of how you can shave micro costs in a tight loop when you understand what's happening under the hood. Let's talk about the time and space complexity. Time complexity is O of n times L, where n is the number of words in the sentence and L is the length of the search word. In real-world terms, this is effectively constant time because sentences are so short in the problem constraints. Space complexity is O of 1 extra space. We're not creating any new data structures. We're not building a try. We're not using a hash map. We're just splitting the sentence into words, which Python handles internally, and then we're doing a clean, fast scan through the words. This is as efficient as it gets for this problem. Here are the key takeaways from this problem. First, the simplest solution is often the optimal one. Don't overcomplicate things just because you know fancy data structures. Second, don't use heavyweight data structures just because they exist. Use them when the problem size and query patterns demand it. Third, use tries when you have large datasets and many repeated prefix queries. Use direct comparisons when the data is small and you have a single query. Fourth, algorithmic intuition is knowing when to scale up and when to scale down. And fifth, clarity over cleverness, always. This problem reinforces a powerful mindset. Efficient code is about matching the tool to the problem, not forcing a tool onto the problem. And that's a wrap for day 21 of our hashtag 30 Days of Code Challenge with Educative. We hope that you liked this video, and if you do, like it down below, share it with a friend, subscribe to our YouTube channel. We'll be bringing much more breakdowns shortly. We'll see you next time.